Hey everybody, so the first review PowerPoint I have for you is on solving equations. So we're going to start with our first example, solving equations with variables on both sides. So as most of you know, you're going to move the variable to one side of the equal sign. So to do this, I would add 7 to both sides. This being the result, 12a plus 2 equals 26. Then you're going to want to get your constant to one side of the equal sign by subtracting 2. With the result, 12 times a number has a value of 24. And finally, you're going to divide by the coefficient 12. With your final answer being a equals 2. So in general, to summarize what you're going to do when you're solving equations with variables on both sides, you're going to identify your coefficients. So in this example, my coefficients are 5 and -7. And you're looking for the coefficient with the smaller value. So in this instance, -7 is the smaller coefficient. And I completed the opposite or inverse of that, which is adding or plus +7 to both sides of the equal sign. Of course, this isn't the first and only step you could do. There are other things you could do, but it's definitely the most efficient way to solve the problem. Once you get your coefficient to one side, you're going to use inverses to get the constants to the other side of the equal sign, and finally complete the inverse of whatever your coefficient is. In this instance, it was 12 times the number, so we divided. So, given that example, if you would please try this problem on your own. You should have got the final answer. C has a value of 5. If you are interested in seeing the steps to get this final solution, here they are. So if we're looking to work as efficiently as possible, my coefficients are 5 and 7, with 5 being the smaller coefficient. So the inverse of that is -5 or subtract 5, with the result being 8 has a value of 2 times the number -2. So I want to get the constants on the other side or opposite side of the equal sign, and I have 10 equals 2 times a number. So my final answer is 5 is C. Right? We should be pretty good at this by now. You guys are probably all thinking to yourself, this is super easy, I hope. So one more example, double check that you've got this under control. You should have got the final answer. F has a value of -2. If you're interested in seeing the steps to solve, these are the steps that I completed, following the directions or summary that I gave you on the first slide. Inverse of the smallest coefficient, moving the constant to the opposite side, completing the inverse of the coefficient. The next type of equation that we looked at in our first unit included distributive property. So the only new step in this process is completing the distributive property, which is essentially just multiplication. I want 3 groups of 6 minus 2x. So the shortcut or fast way to do that is multiply 3 by 6 and 3 by 2, -2. With the result 18 minus 6x. And from there, you follow your previous steps outlined on the first slide. We identify our smaller coefficient, -6, and complete its inverse, adding 6 to both sides. Then we're going to move our constant, -10, over to the opposite side of the equal sign, with the result 14 times the number has a value of 28. Our final answer is x has a value of 2. So really, the only new thing that distributive property does, very first step, multiply. Everything else remains the same. So you see if you can complete a multi-step equation with distributive property. You should have got the final answer. X has a value of 15. So if you're curious to see the steps in between, here they are. I multiplied 2 times x and 2 times -5, and then followed my previously outlined steps. Again, normally, typically, if you all make mistakes with these types of problems, it's with negatives, and oftentimes it's when you're distributing. So make sure you are very careful about that. The next thing we took a look at in class was 3 solution types. So whenever you're solving an equation, typically, when you go through the steps, so in this example, let's distribute our 8 and our 10, and the result is this equation, 40c minus 16 equals 30 plus 40c. So I identify my coefficients, 40 and 40. They're the same, so it doesn't matter which one I complete the inverse of. I'm going to take away 40 on both sides, 40c. And the result is -16 equals 30, which is not true, which is why I've got this slash mark through the equal sign. -16 does not equal 30. So the final answer to this equation is no solution. So in summary, you have 3 types of answers when you're solving multi-step equations, which, by the way, is essentially the same thing as solving a system of equations. We've got substitution here in essence. You've got one solution, x equals a number, which is normally, typically 90% of the time, your answer. Then you've got no solution, just like this example here, which is a false statement. 2 different things equal to each other, not possible. And then you've got infinite solutions, which is the same number equal to itself. So in this example, I would have -16 equals -16, or 30 equals 30 to have infinite solutions. So you give it a try, see what your answer is to this equation. You should have got the final result, infinite solutions, and here's your work in between. You would distribute on both sides of the equation and go from there. Now, when you subtract your coefficients on both sides, you end up with a true statement. 8 does equal 8. So there are infinite possible answers that you could substitute for x in your original equation. Now, you give one more try. In this example, you should have ended up with no solution again. You ended up with a false statement, -5 is equal to -10. Not true. You may have also noticed once you complete the distributive property that there is a pattern connected with no solution versus infinite solutions. Here, for no solution, you have same coefficient, 10x, 10x, and then you have different constants, -5, -10. There's no way you can take away 5 versus take away 10 from the same number and have the same solution. So that's why it's no solution. Versus your previous example where you have infinite solutions, same coefficients, same constants. If you're adding or subtracting the same number to the same number, then it's always going to work out. Okay? And then everybody's favorite, word problems. So here's our first word problem. The length of a rectangle is 4 more than its width. The perimeter of the rectangle is 72 centimeters. Determine the length of the rectangle. Let the variable w represent the width. So one thing I've noticed is you all tend not to draw diagrams when you have word problems. Highly recommend it. It's the first thing I would do here. So I've got my rectangle with the width labeled w and the length labeled w plus 4. From there, I'm going to set up my equation. I know that perimeter is equal to all sides added together. And in this problem, 72 is my perimeter. So 72 is equivalent to all 4 of these sides added together. I combine like terms and solve the equation just like you normally would, subtracting your constant and dividing by your coefficient. Be careful. Make sure you double check what you're looking for. Am I looking for the width? No, I'm looking for the length. So my final solution is taking this value for w, 16, and substituting it for w in one of these expressions here. W plus 4 equals the length. So my final answer, the length of this rectangle is 20 centimeters. Here is an example for you to try. The length of a rectangle is 1/2 its width. The perimeter of the rectangle is 42 centimeters. Determine the length of the rectangle. Let the variable w represent the width. As a hint, please go ahead and sketch yourself a diagram and then set up an equation to solve. So your diagram should have looked something, well, your final answer is this, and your diagram should have looked something like this. Slightly different than the example I did with you because 1/2 its width is represented by 0.5 or 1/2 times the width as opposed to having a plus or a minus sign in between its multiplication. But you still are going to set up your equation in the same fashion. You've got your perimeter 42 equal to all of your sides added together. So the real important piece of these word problems is making sure you label your diagram and set up your equation correctly. Because if you can't do that, then there's no way for you to get the final answer correct unless you're going to sit here and do guess and check for a good 5 or 10 minutes to figure out what your answer is. Here's all your steps in between. Okay, so this is our review PowerPoint on solving equations. I've got some practice problems coming up that I'm going to put in this same folder, so be on the lookout and I'll be in touch.